Welcome to a new video about my two plugins that allow you to control a simulator with the Stream Deck and display information from the simulator on the Stream Deck. In this video I show three examples that all use the new Computed Properties feature. The examples shown are a little bit more difficult than those in the last video. If this is your first time using my plugins, you should first look at other examples and carefully read the documentation available on GitHub. The documentation is linked below in the description. I'm using Euro Truck Simulator 2 again in this video. However, the first example is generic and can be applied to other simulations, for example racing sims. Examples 2 and 3 are specific to ETS2. Let's move straight on to the first example. As you can see, I control the windshield wipers with a Stream Deck dial. If you've seen the last video, configuring the generic button for this function should be no problem. However, my dial also shows the current wiper stage. And that's the interesting part, because ETS2 does not offer a property for this. This is where my plugin fills in the missing piece. We need a computed property. The example requires the use of control mapper roles. Whenever a control mapper role gets triggered, SimHub sets a related property to 1 and then back to 0. My control mapper role is named wiper decrement. If I activate it, SimHub sets this property to 1. If I release it, the value changes back to 0. And we can react to this property change with a script. The script is already prepared for you. You just have to go to the project page on GitHub, navigate to doc, computed properties, examples, and there you can find this script for the wiper stage. You can copy and paste it into SimHub, what I've already done before. So here is the script. First interesting thing to note, it defines a global variable here. That's our current wiper stage. Each script gets executed in its own sandbox, and each script retains the variable values between invocations. So if you write any number to this variable and the script is being executed again, the variable will have the same value as before. So here is our usual init function. We create a new property. I'm using a constant for the property name. It's called ETS2 wiper stage. Then we subscribe to these two SimHub properties because my control mapper roles are named wiper decrement and wiper increment. These are the relevant property names. If they change, I'm calling the calculate function. In this calculate function, we just read the values of these SimHub properties. If decrement is active, meaning it has a value of larger than 0. If decrement is active, we decrement our wiper stage. If increment is active, we increment our wiper stage. Then here are two guards to prevent negative values or values getting too large, and we set the property value, again this computed property. That's basically all to have a new property which is not present in ETS2, and it contains the current wiper stage. Another point worth noting is resetting the windshield wiper to 0 whenever I change the truck. I use the property for the license plate. If the license plate changes, I call the reset function. In this reset function, I'm simply setting the wiper stage back to 0. Usage in the Stream Deck plugin is straightforward. We have an icon for the off state and we display it if the wipers are not active. We have another icon for the on state. We display it when the wipers are active. And here's the computed property. It shows the current wiper stage. And I'm displaying it only if it's larger than 0. So if the wipers are off, you don't see the value 0. The solution is not 100% perfect, and it only works as long as the windshield wipers are controlled exclusively via control mapper roles, but it's better than nothing. The second example is about how much time you'll have left at your destination when you're doing an internal job in Euro Truck Simulator. From this you can figure out if you need to drive faster or if you'll have time for sightseeing along the way. As you can see here, I have a buffer of more than 16 hours. The time to the destination, which you can see directly on the button above, comes from the navigation system of ETS2, and it only shows the pure driving time without rest periods. Therefore, we need to calculate the real driving time, including rest periods. If we have this real driving time, we just have to subtract the real driving time from the remaining delivery time, and we have the buffer. To calculate the real driving time, I have prepared a chart that visualizes the calculation. In this example, we assume that our navigation system tells us that we have to drive 17 hours until we reach at the destination. Of course, we can't drive these 17 hours without making rest stops. So let's assume that we are still allowed to drive 3 hours until our next rest stop. So we drive these 3 hours, then we have to rest for 9 hours. We are allowed to drive 11 hours, which makes 14 hours in total. We again have to rest, and then we will drive the remaining 3 hours. So these are the 17 hours. We have to rest 2 times, and overall that makes 35 hours until we reach the destination. To calculate this, we just have to subtract the time that we are still allowed to drive from our time to destination. That's marked with this red arrow. So it remains 14 hours. We can't drive 14 hours in one piece, so we have to sleep or we have to rest 2 times because we are starting with 0 driving time left. So 14 hours means rest 2 times. And that's basically our calculation. We subtract the time that we still have left until the next rest stop, and from this remaining time we calculate how often we have to rest. So we simply divide this value by 11, which is our driving time. Here we get a result of 1 point something, and we round up to the next largest integer value, which is 2 in this case. So we know we have to rest 2 times. Resting 2 times makes our whole journey 18 hours longer. And these are the 18 hours between what tells us the navigation system and our real arrival time at the destination. Script is also ready to use in the examples section. It's the job calculations script, and it just does what I explained visually with the chart. There are these different properties. Can we put it one on the other like that? Next rest stop time in minutes, that's this value. Our navigation time, which is delivered in seconds by ETS2, that's our time to destination. And at the end we need the remaining delivery time. Just as I said, we have to subtract the real driving time from the remaining delivery time to get our buffer. Here are some constants. We are allowed to drive 11 hours, then we have to rest for 9 hours. And here's exactly the math that I just explained. Our next rest stop. That's the easy case. If our time to destination is shorter than how long we are still allowed to drive, then there's not much to calculate. The interesting part is here. Here we calculate how much pauses we need. The ceiling function is what I just explained. It rounds to the next largest integer value. And here's the formula. Our time to destination minus how long we are still allowed to drive, which would give us this red arrow, divided by how long we are allowed to drive, 11 hours, and the next largest integer value. For our example, it would be 2, so we have to make 2 pauses. So we can calculate the total travel time, which is just the value here, time to destination, plus the amount or the duration of our pauses. And finally, we get the remaining delivery time. That's when our customer awaits us at the destination. And from the remaining delivery time, we subtract the total travel time, and that's our calculated property. Usage in Stream Deck plugin. Here first I show you the time to destination from our navigation system. I've explained how this format has to be used, how formatting is being done in my last video. So just watch the last video if you have questions about this formula. So in our case, 26 hours. And here our computed property is ETS2 job buffer. This one. That's just the value that we display and format here. We convert the value from minutes into hours and minutes, so that we get 15 hours and 51 minutes in this example. I'm displaying that only for internal contracts, because this whole calculation doesn't make any sense for external contracts. For external contracts, I'm just displaying the external job on my Stream Deck. That's basically how you can get information of how much time you have left when you arrive at the destination. The last example is the most complex one in terms of the script. Unfortunately, there are no properties in ETS2 that directly indicate whether a truck or trailer has liftable wheels. For trucks, this is spread across 16 different properties. That's all for the trailer. The truck is further below. Here are these 16 properties for the truck. As you can see, my truck has 2 liftable wheels. The same applies for the trailer, but here the information is spread across 160 properties. I have only one trailer attached. The first trailer has liftable wheels, so we need to evaluate all of these properties, and as you can see, the game would allow us to attach 10 trailers. That's interesting. So of course the script is already available on the project page. It's the liftable wheel script. Again, we subscribe to the license plate, and whenever the license plate changes, I'm calling the function calculate truck. Let's skip this part and go to calculate truck. We get the number of wheels that our truck has, and then we iterate over each possible wheel, and then we read the values or the properties for the truck that I just have shown. If one of these 16 properties has a value of true, we know that we have a liftable wheel. If we found one, we could exit the loop, but because it's not a complicated calculation and because it's only done if I'm changing the truck, I'm continuing the loop so that at the end I can log a small statement that's just for verification, and there I can see how many wheels are liftable for the truck. Then I set the computed property to this value is liftable, which is just a Boolean value. The same for the trailers. There I'm using 2 properties as a trigger condition. Again, the license plate of the first trailer, and also there's an attached property if the trailer is really attached to the truck or not. Then I'm calling the calculate trailer function. It's doing exactly the same, just that here there are 2 loops. First we check if a trailer is attached. If there is no trailer attached, then there are no liftable wheels. And then we loop over each trailer. Again, we check for each trailer if it is attached. If not, we can continue. If a trailer is attached, we get the number of wheels of this specific trailer, and then the same happens as below for the truck. We iterate over each wheel and just verify or check if the wheel is liftable. Again, as soon as one value evaluates to true, we could exit the loop, but I'm doing the whole loop until the end because again, the script is only executed once if we change or attach a trailer. So again, I'm writing a small statement to the log file just for verification, and that's how we get if a truck or trailer has liftable wheels. Here's the usage of that, and I'm just showing different icons. If it has liftable wheels and at least one is lifted, I'm showing this yellow icon. If it has liftable wheels and the wheels are lowered, I'm showing this icon. And if it does not have liftable wheels, I'm showing a third icon. And the same for the trailers, it's exactly the same logic. Lifted wheel if it has liftable wheels, lowered wheels if they are liftable, and a third icon if the trailer or the trailers don't have any liftable wheels. That concludes the examples for this video. I hope this has been helpful in assisting you to get more out of your simulation.